Okay, so the start is recording. Welcome to today's session. I'm feeling tired, man. Yeah, I'm exhausted because I just finished having a session with ComSci 2A students. As you can see here, there's a lot of explanation going on here. So in the previous session, right, I would advise you after the session to go watch the first session, right? So the first session. I don't know why Teams does that. I did put the settings to mute everyone. Seems like sometimes when some people can enter without being muted. You see, I unchecked this, so it shouldn't allow you to speak when you enter. But for some weird reason, Microsoft Teams it does end up making some few mistakes here and there. So as I was saying, I would advise you to watch the first recording to understand about input, right? In the first recording, it was mainly discussing input. So here we're going to talk about output. Then from output, we're going to talk about data types, then variables, then probably if statements if we have enough time. I don't want to push it too long because I'm also tired now. So we'll see, because you guys, unlike computer science 2A, right? You guys have very few chapters to cover. Computer science 2A, there's like around 18 chapters or so. So there's quite a lot to cover in their case. So there's a lot of theory for them. So for you guys, it's chilled because it's divided into. So basically, ComSci 2A, ne, it combines. It's like semester 1 and semester 2 combined into one semester. That's ComSci 2A. So there's a lot of things to cover there. So lucky enough for you guys, I wouldn't have to cover a lot of stuff. We're mostly gonna do past papers. But I think now we should somewhat start with past papers, somewhat. So yeah, let's start. So we're gonna talk about output, right? We did talk about Cin, which stands for common output, and we talked about Cout, which stands for common output, right? Okay, let me mute this person. So we talk about common output. I think I should. Teams does specify the thing. I think I should emphasize that because it wastes a lot of time when someone's audio is on. You are trying to ask a question. If you want to ask a question, unmute. You're allowed. Laura.
Says Cin, is it common output or common input?
Oh, it's common input. My bad. It's input. Yeah, thanks. Then you can mute. So it's common input and common output, right? So Cin, Cout, and they are part of the standard namespace. So you can use them in one of two ways. You can say Cin like this, or you can specify which toolbox are you getting the Cin from. But then remember, this is kind of tedious and unnecessary because you can make mistakes and forget to include it right before every Cin or every Cout or every ENDL end line. So typically we say using namespace std to avoid that. So we did talk about input. That's fine. We covered that. Now we're going to mainly talk about output. So you see that you can redirect. It depends on the direction of the arrows, right? If you are getting input, this is coming from the terminal and going in that direction to some variable, right? That was our input, right? How to get input. With Cout, it's vice versa. So you say Cout in the opposite direction because you want to send the input from your C++ file, which is the whatever main.cpp, whatever the file is. You want to send that, whatever data you want to send it to the terminal. You're not getting it from the terminal. You are sending it to the terminal. So that's why the arrows are in that direction, meaning it's going to that side, to that location. Then here you can either pass in variables or something that we call literals, right? You can pass in variables or literals. literals, it basically means it's literally that thing. So what do I mean by that? So if you have 12, this is what we call the integer literal, meaning that it's literally a number. It's literally an int. So that's what literals means. If it's 12.0, then it's a double literal, right? Then if it starts with single quotes, then it's a char literal. Then if it starts with double quotes, then it's a string literal, right? Meaning it's literally a string. It's literally a char. It's literally a double. It's literally an integer. So that's basically what it means. So you're going to do you output in those two, one of those two ways. You can output a literal or a variable. So I would have to kind of demonstrate it inside code blocks, because if you don't see the code, then it's a problem. Open the wrong thing. So code blocks. So there's code blocks. It's loading. Let's wait for it. Okay, it's taking quite a lot of time to load. That's weird. Guess I must get a new laptop at some point. So when I create a console application, click go. Console, it means that it runs via the terminal. That's what it means. The apps with buttons and whatever, you do that in second year, ComSci 2A. That's pretty advanced stuff. So you better practice now and prepare. Then we choose C++. Then I'll call it output. Then finish. Then I'm gonna go to view and then manager, so that I can see this panel. Then I'm gonna double click on sources, then double click on main.cpp. Then I can just simply close that, because that's not important at the moment. So like I said, you can use literals to display to the output, or variables. So for example, you can literally display the number 12.0. Then if I build and run this, it's going to output 12 on the terminal. So that's cout. That's how it works. You might, yeah, there's a lot of things that, yeah, see, when it comes to output, you might ask yourself, wait, this is not, why is it showing 12 as an integer? It's supposed to say 12.0, right? Well, yes, it's supposed to, but that feature is deactivated by default. So you'd have to set it. There's two ways you can set it, right? There's different settings. It depends on what you want to show. For example, if you want to show booleans, it doesn't actually display boolean, like true. It doesn't show the text true. It shows 1 or 0, whereby 1 means true, 0 means false. So you see, it's outputting 1. If you wanted it to display true, there's something that we call manipulators. So you can, okay, this is not done. You can also output what we call a manipulator. Just like when someone manipulates you to do something. So it's the same thing. You're gonna manipulate cout so that it does something for us. For example, we can tell it to show decimal points. We can tell it to convert all booleans to alphabets, right? Basically, you should use words to output the boolean. So if it's true, it should output the text true. We can also use that manipulator to do that. So this is basically a simple output, right? So what happens when you do output? Remember, the computer is literal. So if you were to do this, right? So let me show you an example. So if you were to say hello, cout hello world. So I'm outputting the string literal, right? Meaning it's literally the string, the value itself, not a variable. So I'm outputting the string literal. What Java, well, we see Java, I was teaching Java. What C++ does, right? It takes one character, one letter at a time, right? And then it displays it to the terminal, including the spaces. You see the space over here. The space is very important here. It's also taken into account. Basically, the string, anything that's inside double quotes, is copied and pasted as it is within the double quotes. That means if you didn't put a space there, it's not going to display the space. So keep that in mind. And if you didn't tell it to start on a new line and things like that, it's not going to know. So let me show you here. Let me build. I think this is not the example, the right example that I want. So you see, this might be okay to an extent, to a certain extent, right? Because there's the process what return. It's on its own line, but it's kind of squashed in one place, right? You might not be sure whether this is actually my output or not. That's why we typically, when we reach here, we tell C++ that we want to append a new line character, meaning this shouldn't start here, it should start in the next line. So we can do that by outputting the manipulator called ENDL. So the manipulator called ENDL in full just means end line. It means the line ends here. That's what it means. It means don't display any text further. No further text should be displayed. So let me make a quite vivid example, right? So if I say hello, and then I do another C output statement and I say world, you might assume that, oh, this thing was going to display on its own separate line. Nope. Because C++ does not see an end line or an ENDL, or you can also use this escape sequence called \n. It doesn't see any of this, right? An ENDL or a \n. So that means you are telling it that you literally want it in one line. C++ reads this as you wanting to output it in one line, one straight line. And there's not even spaces between hello and world. So if I run this, you'll see that it's going to be on one line. You see, hello, world. But I can tell C++ that after O, the line ends there. That's why I can tell C++ by using a manipulator that manipulates my output. We call them manipulators because they're meant to manipulate something. In this case, we have output manipulators, which manipulate output. So that means when it reaches 0 or O here, I can tell C++ that, listen, don't display anything after O, meaning the line ends after O. How do I tell it? So after O is what? Is here, right? I can either put the backslash in there like that. That's the first way, right? So this is what this translates to end the line in C++. You don't have to understand what's the difference between ENDL and \n. For now, just know it's the same thing. But to be honest, it's actually different. There's this thing called flashing and the buffer and all those things. It's kind of different. When you use the ENDL, it flashes the buffer after it's done. I think it's the buffer that it flashes, right? But it flashes. Just like when you're in the toilet, after using the toilet, you flush, right? After use. So that's basically what ENDL does. Then \n, it doesn't. It's like after using the toilet, you just leave it there. You don't flush. So that's the main difference. That's the simplest example I can use. But for now, you don't have to worry about that. Even second semester, you can even finish C++ not ever having to worry about that. Unless if you are really interested, you can go Google it or read the textbooks. It should have mentioned it in some textbook. So that \n, right, it told C++ that, listen, my line ends here. When you after O, it ends there. Don't display anything after O. And it did listen to us, you see. It listened to exactly what it told it because our instructions were clear. If you are talking, remember computers like a child. It is very smart, but it's also like a child. It is the brain of a child. So if you give a child an egg and say, cook the egg, the child doesn't know what, first of all, what cook means. Number two, they don't know that you have to break the egg to open it first before you cook. The child might just, let's say you're that person who's just a risk taker. You don't care about your kids. You put a pot there frying with cooking oil, and then you give your child an egg and you tell them to cook it. The child will just take the egg as it is with the shell and then throw it in the pot because your instructions were not clear. So that's a computer. If your instructions are not clear, it'll just do what it thinks you want it to do. You didn't tell it that you want to display this text on two separate lines. You'd have to be explicit or direct. Don't go through the corners. like females out there, when they want you, they're busy giving signals. We are not forex traders, right? We are like a computer. We don't know anything. If you want to talk to us directly. Don't go through to the corners. We don't do signals. We're not forex traders. So it's the same thing. Don't be thinking you sending a signal to the computer will automatically help the computer and think what you're thinking in your brain. I don't know why why girls like to think that guys are so intelligent they can read their minds or whatever. It's not the case. Even the computer can't read your mind, so you can't assume that it's gonna do what you want it to do. It doesn't work like that way. Be direct. If you want to talk to me directly. Don't go through the corners. That's the compute. So this end line means that end the line there. And to make our output beautiful, we could also, in the last statement, right before return 0, whatever the last C out you have, whether it's like we have many more there, and then this was the last C out, it's still fine. That last C out, I would advise you to always put an end line correct or \n, whatever feels right to you, right? Then if you look at this, I want you to see the output. It's going to be more beautiful now, right? You see, it's more elegant. That \n after world, right? It made the space. So that's why I put it there. Yeah, you can ask a question.
Sir, can you hear me?
Yeah.
Are you presenting your code screen?
Yeah, I am. Are you guys
Because
unable to see it?
I can't see it. I don't know if I'm the only one, because I hear the way you're explaining, it's like you are presenting it to us, but I can't see it on my side. I don't know if I'm the only one.
Can you guys all see? Can you get a thumbs up if you guys can see? Everyone else, can you put a thumbs up if you can see my screen? Yeah, they can see it. So you happen to be the only one. So I would advise you to log out and log in again. Then yeah, let's wait for her to come back. Okay, let me lower the hand. Or else is gonna keep screaming at me. Yeah, that's why sometimes recordings are actually useful. Let's wait for her to join again. Okay, let me close this. Okay, can you now see my screen?
Yes, I can see it now.
Yeah, so if anyone has issues, log out and log in again if you can see or you can hear the audio. Usually it's your laptop's problems. So you can try to fix that by just simply exiting and entering again. So as I was explaining here, right, your computer, it doesn't speak in signals like you women like to do. When you like a guy, you send signals. But you forget that we are not forex traders. We don't do forex. We don't read signals for a living. We can't predict what you guys are thinking. So the computer works the exact same way. Don't be thinking it's gonna do what you want it to do. If you expect it to receive an integer, if your instructions were not clear, it is not gonna think for you. It can't read your mind. That's a computer. So if you want spaces and all those things, you have to put it there. So for example, this \n, it means it's literally to tell the computer that the line ends there. So don't display any text after O. After the letter O, don't display any text. And it did abide by that. It did listen to us, right? This is one way of doing it. You can do it this way too. This is also allowed. You can put it in its own separate string, \n, or you can put it as a single quote, as a char like this, because this \n, even though it uses 2 characters, right? It's actually 1 character. We treat it as 1 character, just like the \t, a tab. So that's why you can store it as a char, because it's treated as one thing. Or for those who like to be fancy, you can say ENDL. All those 3 ways, it means exactly the same thing. They do the exact same thing. So it's up to you what approach feels right to you. but it's always important to teach you all the ways you can do that. Then this would be the output. So now let's talk about different manipulators. Basically, how do you manipulate C++ to output things in the way we want it to output the things? So I'm going to talk about the show point manipulator. Then we have fixed manipulator. Then we have this one is still a manipulator, but technically it's a function because it's supposed to pass in a value there, right? Basically here, no, not show point. What am I saying? Set precision, right? And then here you pass in the number of decimal places inside those brackets. So the set precision one, you can view it in terms of a function, right? So it is a function, unlike this one. So you just use them as they are. So by show point, I mean you literally just go to cout like this, and you say show point. Cout, set precision, cout, fixed. That's what they do, right? That's how you use them. These are some examples of manipulators, right? That we're going to use. I'm going to show you examples right now of manipulators. Then there's the two. Is it two, or let me see, I think only one left here. This one, bool alpha, right? You can read it in this way. Remember in C++, we have the Boolean data type, right? Which is just bool for short, which is used for things like to represent our truth values, right? True or false. It's a variable that stores true or false. We say that variable, it's of type, or its data type, it's bool, right? Why bool? Because the father of logic, right? The person who came up with logic was named George Boole. This was his name, the mathematician. So they named the data type after his surname. So they just removed the E, and then they made that capital B a small letter. Then they had the data type Boole because it was named after him, the mathematician who came up with the Boolean or with logic maths, right? That basically that logic you did in you're doing now. Okay, you guys have 2 first years. The one that you're doing now. If you're second year extended, you did it last year, I think. Yeah, you should have done it last year if you're doing extended here. So logic, basically all of you guys have done logic by now. So this is Boolean logic. It's related to logic. So bool alpha, this just simply means you tell C++ or the compiler to display true, the string true or false instead of 1 or 0. Because what does 1 or 0 mean? The user doesn't understand that. Let me show you what I mean by that. If you try to output true inside C++, by default, it doesn't display it as a string true, unless if you put it in a string. But that's not what I want. I don't want it to be a string. I want it to be its original type. C++ gives you the representation for it. Why 1, why 0? Because a computer, why does it use 1 and 0? Because a computer, we did talk about this in first. I hope I did mention this extensively in the first tutorial when you're talking about input. If I didn't, then yeah, we're gonna have to cover it again when you go to data types. So yeah, we'll talk about the zeros and ones when you get to the data types. For now, let's only just know that if you're outputting true, it's gonna output 1 to the computer. If it's outputting false, it's gonna output 0. If you want to tell it to actually output the string true itself, you send this value or this variable. You output the variable to cout. There's 2 ways you can use these manipulators, right? You can say cout.setf, right? To set something, right? Just know it's called setf. To set something, right? For example, you want to set it to show point. The show point, let me give them a short description, right? To show points, it shows the decimal point, right? Even if it's a 0, even if it's 1.0, it's going to display 1.0 instead of 1. That's what the show point manipulator does. Fixed, it just means that you output the decimal point in a fixed manner, right? That means it's fixed, right? In a fixed manner. Then set precision is to set the number of decimal places for that value you're trying to show, that decimal you're trying to show to the user. Then bool alpha, it tells the C++ or the compiler that instead of outputting ones and zeros to the terminal, output the strings true, or output the true itself and the false itself. Don't show me ones and zeros because I don't understand what ones and zeros mean. So this will be the first way to set it. I'm showing you this first way to set it. Don't worry about the F right there, right? Just pay attention to this. It sets to set it, right? To show the decimal point. It's called show point. Pay attention to the capitalization. It's in all small letters. C++ is not your friend. Don't be saying out of the blue, you're saying show pointer, capitalizing P. Error. It won't run. Do exactly the way I've named it. Small letters everywhere. Everything that I've named, it's in small letters. Don't be doing spiritual things. Then to undo this, right? This is how to set it, right? This is one way to set it. I'll show you the second way, but let me show you how to undo it before I show you the second way. To undo it, you say cout dot unset f. Which means you're unsetting it, you're undoing it. Then you specify what do you want to undo. So it should stop showing the points. So this is the one of the two ways to do it. But then just make sure that whatever you pass in the manipulator you're passing here, right? I'm not sure about the set precision. We can try. Yeah, I think the set precision is fine. We can try it because since it's a function, we can try it. So we have cout unset f blah blah. Then to set it, this is another way. You can just simply say cout, like you're outputting a variable. Remember, you included the IOStream library, right? Or the header file IOStream. It's part of the IOStream library. You don't have to worry about it. It's part of this. It's already included in your project. So just use it, just call it. So if you see, if I go to my code blocks, right, I'll say show point. You see, it's now showing me the point. There's also a show base. There's also show position. C++ is very big. Even the person who made it, he said it's impossible to know everything in C++. So don't be asking me, what does this thing does? What does this thing do? It will take 2 years only doing this module for you to finish or to be close to finishing. There's quite a lot. You might even not finish. There's quite a lot. So the rest, the university just teaches you the basics. You go do your research if you want to learn more. We're not going to touch into everything because you don't use everything in your breaks, right? So we're not going to touch on everything. I'm going to touch on the important stuff, just like this. So to set it, you can set it in this way, or you set it in this way. But then to unset or to undo it is one way. It's this way. You're just going to pass in the manipulator here. It could be, the manipulator could be fixed. So you're undoing fixed. It could be show point, you're undoing show point. So let's test it out, right? Let's say I want to output true, but you need to set the manipulator or to use the manipulator before displaying the values, or else it's not going to work. Let me show you. Let me say I display it after, and I say cout bool alpha, right? The bool meaning Boolean, right, to alphabet, right? That's what bool alpha sort of like stands for. It means convert it from the numbers that it's displaying to alphabets, basically text. Instead of me seeing ones and zeros, it's going to literally show me true. But then you'll see that it's not going to work because remember, C++ reads from top to bottom. By the time it reached line 9, this was not set yet. So it's going to show 1 here. But if I try to display after setting it, that's when it should start, it will now start working. That's why you need to understand what you are doing. Things should be done in sequential order. So you see, it's still outputting 1 because of the order of operations, the order I used my things. So I'm going to cut this, then I'm going to put it here. Before I output the value, I'm going to change. You can think of this, you see when you use manipulators, right? Think of it as like you're changing settings. in your C++, in your output. That's all. So now when I run this, it's going to show me true. This is better, right, than seeing 1, because what does 1 mean? I don't know what 1 means. 1 could be a number in my app or an answer to something. So I don't want it to do that. Then you can undo it, right? So remember, C++ reads everything sequentially, right? So I'm going to come here and undo it. So unset F, right? Unset or undo the Boolean to alpha. That means it goes back. That means it's like, how do I put it? It's like in your phone, right? You have settings, then you click the button restore to default settings. So that means this will restore to default. Then after I've restored to default, let me try to output true again. Then end line character. You'll notice something. Remember, it reads top to bottom. It's going to read this line and then change my settings. So that means every Boolean I output is going to be displayed as it is, not as a number. Then I display here, then it's going to output true. Then I update the settings again here. I undo what I did here. Then that means when I try to display this, instead of showing me true, it's going to show me a 1. So that's what I'm expecting as my output, true and 1. Okay, seems like this thing doesn't want to. I did read the textbook. It was there in the textbook. That's the thing about C++. I don't like some of these errors. What does it want now? No matching function call to. I don't know why it's saying that, but that function, I did check it in the textbook. And then sometimes you see the problem with the textbook, it shows you kind of like old ways of doing things, right? Then let me try to remove that. Let me see if it might work now still. Yeah, I don't know why it's doing that. This is supposed to work. If you read the textbook, the one that's there in your learner's guide, they literally showed this in the textbook. So the fact that it's not working, I also don't know. Because it's simple. You just say unset to undo something, then you pass the thing that you want to undo. Let me try to pass show point. Let's see if that was to crash. Yeah, I don't know what's going on, but this is how it's supposed to work. To undo something. That's the exact way you should do it. I don't know why it's doing that. I wish I knew, but yeah. So I won't demonstrate that since it's refusing to work. I don't know why, but that's how you undo it. I'll try and test like this is why I don't like code blocks. It's better to use Visual Studio than code blocks. I'm sure they mentioned it in the practical. I saw it in your practical, the one that's due. I think it's due next week, right? That practical they gave you. They did say that there's some links on how to set up Visual Studio to run C++, blah, blah. There's bonus marks on that, blah, blah, blah. Visual Studio is way better than this thing. Code blocks, I don't know. Code blocks is something else, man. Code blocks is literally something else. Let me just double check something here. Just give me a sec. I wanted to test something here. Because I don't know why C++ does that, especially inside code blocks. Okay, I still have the compiler installed, so let me test something here. Let me put back that code. Let me run it using that compiler and see if I get the same error. So my projects are stored inside code blocks. Projects, this one is I called it output. Then there's main.cpp, right? So I'm gonna say new, no. Okay, open in terminal. So I'm gonna try run it via the terminal and call the compiler there and see cpp dash main. Okay, let's see. Okay, it seems like it's common. I thought it was on. And what are they talking about in the textbook? Because I took this from the textbook. This is what the textbook says. Unless if you're supposed to use a different version of C++, but this is, let me see, this is C++. 20 what? Let me check. It's 2023, right? This is the latest one. No, 2024. Yeah. So this is the latest C++ compiler G++. So the fact that it's not working, it baffles me. I don't know why it's not working. Error show point included, blah, blah, blah. Initializing argument 1 of flags underscore mass. Yeah. I don't know why it's refusing, but if you check your textbook, I'm not writing something that doesn't exist. This thing does exist. I saw it in the textbook. But for some weird reason, when I try to do it, it doesn't work. That's the problem when you use old textbooks. Yeah, don't trust those textbooks too much, especially if they're too old. So let's just not focus on the undoing part. Let me go check it out first and find out why it's not working. Then I'll come back to you. I'll tell you in the group. So we've tested bool alpha. We see that it works. Let's test out what is this? Let me actually create a variable for it. So double number is just going to be 1 divided by 3, right? Then I'm going to try to output that number. But since we're about to talk about data types now, I'll mention them. You'll understand why I'm doing what I'm about to do. If we leave it like this, right? What you are telling C++ is that you want to get the quotient because you're dividing 2 integers. You should make at least one of the numbers to be a double in order to get a double value as a result. We want it to return a double. So any one value, you can turn it to a double by simply adding 0.0, right? So it's any variable or both if you're feeling that energetic. But I'm just one should suffice, should do the thing, right? So you see, there's 0.33, right? This one does show, even though, why does it show? Because it's greater than 0.0. So that means there's no 0.0 under it, right? So if I was to try and do this and say divided by 1.0, this will just give me 1.0 as the answer, right? Well, if you look at the output, it's going to show 1. Where's that 0.0? So the way C++ displays stuff, right, especially the doubles, it displays them only if it starts from 0.1 going upwards. If it's 0.0, it won't display it. You have to tell C++ to show that decimal point. So you have to say cout show point, which means that show the decimal point even if the number after the decimal point is just a 0, it's just 0.0. Still display it, show it. I want to see it. That's what this does. Then I'm going to build and run. Now you see that even if it's a 0.0, it's now going to start displaying. You see, even if there's zeros, it now starts showing them. It shows those decimal points. That's all it does. That's when you are dealing with a prac whereby you're supposed to show the decimal points and all those things, blah, blah. That's where you use it, the show point manipulator. When you're working with the, especially in C++, when you're working with the prac, that forces you to, for example, round off and things like that. What if I want to round off? You see that by default, it shows, if you check here, if I run the app, right, you see that by default, it shows a specific number of decimal places, right? So we need to limit it to a specific number of decimal places. How do we do that? We use the set precision function, right? Or the set precision manipulator. They're called manipulators, but then it kind of looks like a function. So you say cout set precision to set the precision, meaning the number of decimal places. Then inside the brackets, you put in how many decimal places you want to round it off to. I want to round it to 2 decimal places. So that means before this number, before C++ gets here, it's going to apply that manipulator. That means every double will now be displayed to 2 decimal places. Then here I'm outputting a double. Even a float, as long as it's called, they're both called floating point numbers, right? I'm trying to understand what's going on in C++. I don't know. One moment this thing doesn't work, one moment it works. I also don't understand. In my recordings for last year, the things were working nicely. Set position was not. Oh, I think, oh, my bad. I remember. That's my fault. These things are not actually part of it. They are part of IO manip. Yeah, IO manipulation. My bad. I think the unset thing was, let me see if it'll work now. Let me try that. I forgot that these things are part of that library. So unset f will alpha. Let me see if this would work or it still doesn't work. Yeah, it still doesn't work. But I forgot that all of this, most of these manipulators, they're part of IO manipulation. IO manip header file. In full, it's IO manipulation, basically meaning input and output manipulation. So you need to include that if you're manipulating your output or your input. So show point. Oh, yeah. See, you see, you need to really understand what you're doing. Remember, we said that in C++, if the number, right, after the decimal point is a 0, it's not going to be displayed. So we need to use two manipulators. So we need to start by telling C++, listen, and please don't do spiritual things, guys. This is not output. These are manipulators. You don't ever put an end of line character. Don't ever do that. You only pass the manipulators as they are. Like I said, these manipulators are for changing settings, not for outputting. They just change settings. So here you need to also say show point to show the decimal point, because here we're getting a number below 0.1. So we need to show it. After showing the point, remember it's going to show it to a specific number of decimal places. We don't want all those decimal places. We want 2 decimal places. So I'm going to set precision to 2. Then after I've done all those settings, now I can display my numbers. Then let's run it. You see that now it should say 1.00, 2 zeros. It didn't display, but it's supposed to display. There's supposed to be 2 zeros. I guess it displays up to 2 decimal places, right? Here there's just a 0. It's insignificant. Seems like it. But if you had something like, I think this should demonstrate it well. If I say 1 divided by 1.5, I think that should now show the 2 decimal places. Yeah, so the zeros, it kind of neglects them, it kind of ignores them. If there's 2 of them, it just says, what's the point? It's just 2 zeros. So let me just show 1 0. I don't know why, who told it to reach that conclusion. Yeah, pap, it's too forward. If we want 2 decimal places, we want them, even if it's zeros. It was not supposed to think for us. So this is 2 decimal places, you see. If I was to remove this line, it would deactivate those settings. So that means it won't round it off. It's going to show a very long number. Not too long, but yeah, you see all those decimal places. So yeah, that's how the manipulators work. You just send them to see out. Remember, they're just manipulators. You're not outputting. Don't be doing spiritual things. I think the fixed one, right? You see the fixed. I think that we can use that to force it, even though it's going to have just zeros after the decimal point. I think when you also use the fixed manipulator, it's going to put it in a fixed form. So I'm going to say cout fixed, right? I think now it should work 100%, even if it's 2 zeros. Let's see. Can never be sure. Yeah. So fixed. So that means C++, it like I said, it's not fixed. It plays around. It looks at the values. If there's 2 zeros, it only displays 1 and all those things. I don't want that. I want it to be fixed. If I say it's exactly 2 decimal places, it's exactly 2 decimal places. Even if there's zeros, give me back those exact 2 decimal places. So that's what fixed is for. I'm sure you can see now why we need fixed. So you'd have to, if you want to display up to 2 decimal places, you have to use all 3 of these manipulators. You must first force it to show the points, even if the average that you get or the double that you're going to output is going to be containing a 0.0. Tell it to still display it, to show that 0.0. We want to see it. Then also tell it to be fixed, even if it's 2 zeros after the decimal point. it should show it in that fixed form that we want to see it in. Then here we round off to 2 decimal places. It's called setting the precision. And then we talked about bool alpha. And then, yeah, that's pretty much all the manipulators you have to know when it comes to output. Then there's, not all of them. Not all of them. There's a one that I wouldn't think I don't think you guys would use it, but it's called set width W, right? And then here you pass in the width size. Basically, this is for formatting output. When you want it to be in a table form, you use set width. So let's demonstrate that. Let's use set width, right? So let's say I want to output my string number, then end of line character, then that number, after that number, I'm going to output the actual number itself. So cout num endl, right? So I've displayed the number. So there's the number. Then my output is going to be number on its own line. And then in the next line, you're going to have num as the actual number, which is going to be 1 point. In this case, I removed those manipulators. So it's just going to be 1. So you see, there's the numbers, right? So, but what if you want it to be in table form? So you want it to output some text here, and then a space, this text here, and then some space here, and then some text here, some space again, some text here. How do you do that? So let's try to do that. Let's try to demonstrate that, right? So I'm going to say this is divided by that. Then I'm going to say, let me rename my variable. So this will be value 1, value 2 is equals to 3.0 divided by 2.5, 2.4. Yeah, I'm just putting random things there. And then value 1. And you don't want to end the line, right? Because you want it to be on one line. So that means you'd also want to output value 2 here. But then you start to notice the problem here. It's gonna show there's an output value. Okay, there's no. Then I'm gonna have value 1, and then value 2, and then ENDL, right? And then you notice something. The output is gonna be very ugly, right? It's gonna be very, very ugly. See, there's my output, very ugly, right? We need to fix that. So before I fix that, let me put in an end of line character here, so that we can see the output properly. Because I want the headings to be on the top on their own, and then at the bottom I want the values to be on their own. So you see how ugly this thing is. What if I set it to be to have spaces in between each input? We call that set width, right? So you're setting the width. So usually the way you set the width is you set the width before displaying that thing. Then you display that value most of the time. So I'm going to say set width, set W, right? What's the width? So 8 spaces, right? Because it has to be an integer number. How wide should the spaces be? So if I run this, right, it's called write adjusted, right? Yeah, I think that's what they mean. It's write adjusted, meaning it's adjusted to the right. You see that this value 1 string, it was shifted to the right. So if I want to have this space before every variable, I need to call set width before calling every variable. I'm sure you can see the pattern, because this set width here, right, it only applied to the string. So that means before calling each and every single variable, I'd have to call set width. So I'm going to change my code to this, and then cout with that. Then I'm going to cout, then I'm going to set the width to 8. Right? So that means it's going to be a maximum of 8 spaces. That's up to you how many spaces you want to use. Let me say 12. So what you can do, right, to get the number of spaces, you can look at the string, how many characters it has. So 1, 2, 3, 4, 5, 6. The space also counts. 7. So we have 7 spaces. So when you put a width that's greater than the string itself or the number of characters it has, it'll append white spaces and shift it to the right. It's called right adjusted, meaning it's adjusted to the right. If we happen to have a bigger width than the string itself or the text we're trying to display. So here I just wanted to add two extra spaces, right? This space and this space, just two extra spaces. So that means it will be 1, 2, 3, 4, 5, 6, 7. 7 plus 2, that's 9. So that means I'll tell it the total is 9 spaces. It's 9 characters. Then C++ will do this. It will count. It will be like 1, 2, 3, 4, 5, 6, 7. So 7 have been covered. That means I'm left with 2. Therefore, these 2 spaces, I'll add it in front of the string, basically shifting it to the right. So that's why I said 9, right? And I must be consistent everywhere. 9. And then this end of line is important so that we have it in table format. Then here, I need to also set the width. So, and usually use the same width to make things consistent. And here, I'm gonna display value 2, right? Before displaying value 2, I set the width. Set the width to be 9. Right, so now you should output it in table format. So let me remove the spaces because it's going to add them for me via the set width manipulator. Then I build and run. There's also set fill. There's a lot, right? So you see now it's in the table format. You see now everything is aligned. You see it's aligned perfectly here, aligned perfectly here. Remember these numbers we have to round them off to 2 decimal places. Then it will output in a proper table format. So this would be how you output in a proper table format. And then you can also call a function called setFill, right? A manipulator, but it works the same way as a function. There's also one that's called setFill, right? 2 L's. Then you pass in a char here. It expects a char, right? So you put in the character that you should put in place of those spaces. Remember, if the width is bigger than the string or those number of characters, it appends spaces. The set fill, you can tell it no, instead of spaces, for example, I want stars. So I want stars instead of spaces. You can do that. Or I want hyphens instead of spaces. You can do that by using the set fill. So I can say cout and then set fill, right? Then I'm going to specify that I want it to be the char star, right? But then I think, like I said, you have to set the fill before every single variable. So this it should only apply to one variable or one text, which is the value one. Oh, okay, it does up. Oh, set fill is better than the other one. It applies it to everywhere. So you see, instead of those spaces that I was talking about, I told you to set a fill, meaning a symbol that is gonna use it to fill in those spaces. So it's a star. Like what's that girl? Like Megan Thee Stallion said, Watashi wa star. So it's that star right there. So that's how the set fill works. That's pretty much the most. If you know all of these things in C++, I would say you're an advanced user of C++ because these things are quite. It takes a bit of time to know them by head and things like that. So if you get to that point where you know them by head and you understand them, perfect. You're going somewhere in life. So there's the example we're done with that. We're done with output. Yeah, that's what I've been explaining a lot here on output. So let's go to variables, right? So we're going to talk about variables. For you guys, you're doing C++. C++ has pointers, so I would actually have to demonstrate the diagram for you guys, right? For the variables. But we did somewhat, I think, but then that was for arrays. But it's similar to that, right? It's quite similar to that. So I'm gonna call this variables. So there's the variables, right, that we want to demonstrate. So there's something called main memory, right? So what is main memory? When you create your variables like a double, int, whatever, all these variables, they get stored or get loaded into what we call main memory. That's where they are stored inside of your computer. There's a place called main memory. So that's where they're stored. And inside main memory, you can, like I said in the previous video, when explaining arrays, yeah, I think it was arrays. Think of variables as boxes, right? Think of variables as boxes. Then copy, paste. So this will be you can think of this, the main memory is like it stores drawers, right? This will be your drawers. And then for ladies out there, you can have your drawers for makeup, your drawers for your socks, for your drawers for what, all those things. You have each drawer stores its own things, right? So that's basically how the main memory works, right? You have drawers or shelves that you store these variables, which are just boxes. And then each shelf or each drawer has an address. Basically, this address tells us, it helps the computer locate where that thing is stored. But we don't want to work with addresses, so we don't typically use addresses. But when it comes to pointers, that's when we really want to work with addresses. In this case, we're still on variables. We're not working with addresses. So I can say 1F, 22, whatever, just a random. So this is a data address. By address, I mean, for example, when you go to visit Chomi and Chomi sends you her address, Chomi is giving you an address of where she stays, right? So that's her address. That's where she is located. Computers, they copy from that concept. They just copied from that concept that people stay at houses with addresses. So each of these boxes, right, they are stored at a specific address. And the address points to that shelf itself, right? So that you know, don't worry about the same. Let me change it because for some weird reason students, they get confused when you use the same values. When I just copy and paste, it doesn't matter about the address. We don't care about the addresses. They're not useful in any way to us. Don't be asking, why am I repeating? I'm just copying and pasting so that you see that each shelf has an address. It's not useful to us in what way, in any way whatsoever. Even when we work with pointers, we don't need to know the actual address. We just refer to the address. We don't care about it. But just know it uses hexadecimal, of which you did cover that when you're preparing for semester test 1, right? Go revise on your slides on that if you forgot. So when you create a variable, let's say you created a variable value 1, right? This is value 1. This was 0.6267, right? So that's the answer. So that's the value inside the box. So what you are telling C++ when you create a variable like this, you are telling C++ that the label on the variable is the name of the variable, which is value 1. In this case, you could have used a more meaningful name like sum, a meaningful name. But in this case, we're just going to use the generic name, just value 1. This is what you are telling C++, that the box has a label, value 1. And I'm sure you know the importance of labeling things. Imagine if you're in a garage, right? And your parents sent you to go look for something inside the box. And each of the boxes, they neither have a name or a label, nothing. And there's 240 boxes in the garage. How long do you think it's gonna take you to find it? A very long time. Because there's no labels on the boxes. That's why we have variable names, so that it makes it easier for us human beings to work with the data. Because if you try to use the addresses and cram the address keeps on changing, which is impossible for you to keep on cramming it. Next moment, you see while I'm running this application right now, right? These variables have different addresses, right? They have their own addresses right now. If I switch off the computer and I run it again, the address would have changed. So you can't keep track of addresses. That's why we give them names, so that C++, when it goes, it looks for the right shelf with the right address, whereby that box, it has that label. It makes it easier for C++, right? Even for us. C++ wouldn't actually care, but for us, we're trying to make life easier for us, right? Remember, we are human beings. We are very bad when it comes to things like numbers, right? So it's best to use words than numbers. Then the data type will tell the computer, right, what type of things can go inside here. And don't be mixing things. If you remember when you go to Pick n Pay, right, or Woolworths anyway, or ShopRite, when you buy something, right, and it's inside a container, they don't mix things that aren't supposed to be mixed, right? You don't park your car inside a microwave, right? Because that's not where the car belongs. It's two different things. So the same applies with boxes and variables, right? If you told C++ that this box can only take in doubles, why would you try to put a string? That's when it starts complaining to you. So if I try and do this and say hello, C++, what it does, it checks the type of what's on the right-hand side of the equal sign. If this type doesn't match with this type, error. So if I try to build this, C++, let me translate it in a way that you can understand. C++, when it sees that line 9, it thinks you're trying to pack a car inside a microwave, which is very stupid, right? That's basically what C++ was trying to tell you. Don't be doing weird things. Because when you tell it that it should only store a double, remember, you are telling it. You can't tell it to do this, and all of a sudden, you break the agreement here, this side. But we had an agreement, Monsieur. You said it's a double. Why are you putting a string? So it checks. Before you put a value, it checks what data type that box can store or what type of things this box can store. To make it simpler for some people who still don't get it, but you should be getting it by now. The data type could be, for example, this thing stores noodles. This box is noodles. I wouldn't expect to open this box and find stay soft because it's written that this box contains noodles. So yeah, just like, for example, you order clothes from Temu or Shein or Nike Factory, or whatever you're ordering the clothes from, or Superbalist. When you order your clothes, right, you don't expect to receive grocery, right? Exactly. So that box, it can only store that one thing. Don't be putting things that don't belong to that box, or else errors one way. You're gonna get an error after an error after an error after an error. And the way C++ works, right? If there's an error here and you use the value somewhere down there, it also complains down there. So be very careful in understanding and understand what you're doing. Don't just be cramming and copying and pasting. I hope you guys have attended the tutorials for game when they're making games. You saw how much code that is. Do you think you can cram that and it's gonna run? I doubt it. I've written that test with students and you're sitting right next to some student, and the person was crammed their code and then they're flowing. Then they try to implement this one function and then it gets red everywhere. There's red. Don't beat those students. Don't cram. It's not going to end well. Trust me. You want to repeat the module nicely. You'll find Stung waiting for you again next year. Don't cram. That's why I'm taking my precious time to explain this thing, even though it's taking a lot of time, but I want you to really understand what's going on. So each box or each variable is stored in a specific drawer or shelf. Each drawer has an address. That box, when you create a variable, the name of the variable is the label on the box, basically what the box stores. Then the data type, it describes what type of things go into the box. Don't be parking your car in a microwave. That's impossible. So we understand that, right? Hopefully everyone understands that. Now let's talk about the different data types inside C++. But before we do that, let's talk a bit of a history on computers. Which language does it use and why are we doing the things that we do, right? I'm tired now. I've been speaking a lot. So let me see. So we're gonna start with the language of the computer, right? It's machine language, right? Or some would call it machine code, right? It's up to you what terminology you want to use. Either one is fine. This is just the mother tongue of the computer. Basically, this is for those who did home language. This is the computer's home language. And I want you to understand the computer, right? A computer is like a taxi driver. It's very stubborn. It only wants to speak its home language. You either speak its home language or you go elsewhere. It doesn't care about your feelings. So you go there to taxi rank CBD and you're like, Dumelang, taxi. You're asking how much is the tax. And then what they're gonna do is that those taxi drivers, they have this tendency of looking at each other. They're like, wemkhona uthini lo yazi angimuzwa umtshele mangabe safuna ukukhuluma nami angitshele. So basically they're looking at each other and saying they're like, this person is basically they're offended by you speaking a language that's not theirs. They're like, then they talk to each other, then they say, one driver talks to the other driver, he says, tell this lady or this person when he or she is ready to speak, they'll speak to me. Because clearly they're not ready to speak. They're speaking in a language other than my home language. That's how that's a computer. Think of a computer as a Zulu drive. That's a computer. It doesn't care about your feelings. That you also only speak your home language. You rather butcher that Zulu, and that's so that you can get to the text. Or else they'll tell you to go elsewhere. And when you go elsewhere, there's other Zulu drivers again. So you see, you're forced. It's abuse. But yeah, that's a computer. I want you to picture it in that way. So the computer is stubborn. It only speaks in zeros and ones, right? These zeros and ones, they represent a state, right, of the computer. These zeros and ones, they actually come from, they represent something that are called transistors, right, inside a computer. Those transistors are basically electrical switches. Like the switch in your room right now. You can click that switch to switch off the lights, right? So you can imagine that this follows an approach called on and off, right? So on will be represented by the number 1. Off will be represented, off will be represented by the number 0. So that's basically how the computer works. Because if you remember that, just remember, right? When you use your phone or your laptop, don't you charge it? Why are you charging it? Because it uses electricity. So that electricity, it's either the computer uses what we call transistors, which is like small electrical switches. You can imagine that the small switches in the computer, it has them. But I want you to be able to picture it. It has them. If you were to take a screwdriver and open your laptop right now, it has those transistors. Or in some case, we call them electrical switches to help you get a mental image and understand, picture them, which basically represents 2 states, on and off, meaning there can be a presence of current or electricity or no presence of current or electricity. So it can be on or off. So understand that. So now you might ask yourself, how do we represent things in computers if it can only speak zeros and ones? Well, to represent numbers, it uses what we call base 2, right? We use base 10, right? Because there's 10 numbers that we can use to represent any number. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are all the numbers we can use. Base 2 is basically that number that represents how many numbers inside that number system. In this case, for base 2, it's just 0 and 1. So we can only use the 2 numbers to represent any number, even letters. To represent letters, we'll talk about it when we get there, when you get to strings, but I can give you somewhat of an introduction. For numbers, you might ask yourself, how does it represent letters? It represents letters through something that we call an ASCII table. So, for example, if you want to output this exclamation mark, right, it's the integer number 33. So ASCII table just means that every single symbol on your keyboard, it has an integer number to represent it, of which that number you did write semester test 1, right? That integer number we can convert from dec or decimal to binary. So this is the binary representation of it. So therefore, we can actually represent everything in a computer. We can represent colors, we can represent images, we can represent words and sentences using simple zeros and ones. So don't be shocked about how it represents it. It does represent it. Everything in a computer, it boils down to zeros and ones. So you might ask yourself, how does it represent? You might ask yourself, why did they say base 10? They say base 10 because there's 10 numbers and that's the base. If you remember in high school, you say base to the power of some exponent. I want you to pay attention to something here. I'm mainly talking about maths. ComSci is a maths degree, if you didn't know. Fun fact. So if you hate maths, you're in the wrong department. ComSci is maths YY. I'm going to be revising maths one way when I'm explaining all of these concepts. If you still remember, base to the power of some exponent, right? Hence, they're saying base 10, base 2, meaning that's the base. So let's say I wanted to represent the number 123. How do I represent that? I break it down into tens, hundreds, thousands, and units. You see, maths again. So you need to know your maths. So 100 plus 20 plus 3 gives me 123. But what is 10? Now I need to find a way to represent this whole equation in terms of 10 because I'm trying to get to this base 10, right? So this will be just 10 times 10 plus 10 times 2. And then remember, brackets are very important. And then plus 3, right? But then I want plus 3. Okay, let me just write it. Plus 3 times 1, right? Then how do I, what is this? Remember in maths, if you have multiplication whereby the bases are the same, you simply add the exponents. Like I said, if you don't like maths, it's not the place to be. And why am I starting here? Because I'm using BODMAS. So start by brackets off, then division, then multiplication, then addition, then subtraction. So start with what's inside the brackets. This is just 10 times 10, but the bases are the same, 10 and 10. So I can just add the exponents. Imagine, remember in maths, there's an invisible 1 in every single number, right? An exponent 1. So that means this will be 10 to the power of 1 plus 1, which is just 2. So 10 to the power of 2. Plus this, which is just 10 on its own. So it's just 10 to the power of 1 times 2. And then plus 3 times, how do we represent 1 in terms of 10? Remember, any number with the exponent 0 is equals to 1. That's a mathematical law, right? A property. Like I said, there's maths one way here. So plus 3 times 10 to the power of 0. So now I'm sure if someone attends this session, they'll be like, are you guys learning maths? And no, we're learning ComSci. Like I said, ComSci is maths. So this would be how you represent the number 123. Even though they didn't teach us in high school, they expected you to go do your research and find out. But the whole time, this is why they called it base 10, because you use that base 10 to represent any number, even 1,000, 1 million, any number. Then now, how would I use base 2? Let's look at base 2. So base 2 is the same. Okay, before I continue, let's notice something. You see the rule, right? It's the exponents. How do you come up with the exponents? You start from 0, starting from the right-hand side for the units, right? And then you go to 1, exponent 1, exponent 2, exponent to the power of 3, to the power of 4, and so forth, going to the right, to the left, I mean. You always increase by 1. So as you can see, I have 10 to the power of 0. So I'm following that rule. Then the next one is 10 to the power of 1. So I'm still following that rule. The next one is 10 to the power of 2. I'm still following that rule. So the same applies here. I'm going to have this number. And you saw how I broke down this one. I'm also going to break down this one. But then this one just says, let me see. Yeah, you can. Okay, the right way of doing it, the thing is I'm avoiding to take too much time, but the right way of doing it would be 100 plus 10 plus 1. This is the proper way, right? Whereby this is not 100. This is in binary, right? So this will be position Yeah, this will be position 0, 1. Yeah, position 0, position 1, position 2. So this means this number is actually the integer 2. But we're not going to focus too much on that. So I'll just remove the zeros for me, right? I don't see the need for that. Then here I'm gonna have 1 plus that plus that plus that. Remember the rule that I talked about. It applies to all number systems, whether it's hex or oct, or they're all the same. The rule is universal. So here I'm gonna have a 2, right? So you start from 0, power 0, power 1, power 2, and so forth. But then looking at the base, the important thing is the base. So here is base 2. So I'm gonna say base 2 to the power of 2 times 1 times this 1 over here, right? Then that's my first answer, right? Plus the second part, 2 to the power of 1 times 1, and then plus the last one is going to be the power of 0. So 2 to the power of 0 times 1, and then there's my equation, right? So this would be, in a way, right? This is actually, I'm doing something that you never expected it to happen, right? We never really expect to happen what we're doing right now. We're actually converting from binary to decimal, but that was not the intention. But the intention is just to demonstrate base 2 and why do you see that it's exactly the same as decimal or the decimal number system or DEC. Decimal number, this is just a history lesson. Decimal number, the word decimal comes from the word DEC. DEC meaning 10. You can go Google it. That's what it means. By why 10? Because we have 10 numbers to represent any number in that number system. You might argue and say that's false, but you realize that it's actually true. So if I was to take the number 150, which numbers did I use to represent here? This number. I used the numbers from this system. I used the 1 to represent my hundreds. I used the 5 to represent my tens. I used the 0 to represent my units. Then I got 150. So I used only the numbers that belong here to the set. Going back to mathematics now, if you're skipping banking classes, yeah, now it's going down. So this is 2 to the power of 2, which is 4. 4 times 1 is 4, right? Plus 2 to the power of 1, which is 2. 2 times 1 is 2. And then plus 2 to the power of 0, any number to the power of 0 is a 1. So 1 times 1 is just 1. So this would actually give you the decimal number 7. So this actually means that 111, in terms of decimal or DEC system, which is the system that we use, it's actually the number 7. So that's basically binary, right? So I was explaining to you how it represents. We're gonna need to understand that so that you understand what I'm about to do now. I'm about to list the data types that are the different data types that are inside C++. There's quite a lot, like a lot. Like when I say a lot, it's an understatement. There's a lot, like like a lot. And the data types in C++ are a lot. You can never like really understand all of them. There's things like about int 8. I think it's 8 underscore t, something like this. There's a type like that. There's a lot of data types in C++, but we're not gonna focus on all those ones. Those ones are for specialized cases. For example, when you're making apps that are supposed to be embedded, we call that embedded systems. Basically, something that you wear in a way. For example, a watch. Those data types are used to make apps that run on watches. So we don't have to use those types, as we use simple types. So let's list the types, right? So before we list the types, the zeros and ones, right? We call these binary digits, right? Or bits for short. You might ask yourself, where does this word bits come from? If you look at the two words binary digits and you delete from here up until there, you're left with bits, right? So it's an abbreviation of binary digits. Bi meaning 2, 0 and 1. So we have two numbers in that system, now in that number system. And then if you have 8 of those numbers, 8 of those zeros and ones, we call it a byte. So it's 1 byte, or just in short to say it's a byte. That's something you should know before we move on. So we understand the binary digits, we understand the bits, we understand that eight of those zeros and ones, they are equal to 1 byte. So we understand that very well, right? Then now we can talk about the data types. So the data types that we have, right? I'm gonna start with the smallest one and then I work my way up. So we have the char data type, right? Then we have the short data type. Then we have the int. Then we have the long. Then we have the long. Like I said, C++ is really a pain in the ass. C++ is not nice. The types are a lot, and this is what we call signed, right? Hey, yeah, this thing it'll make you angry. But yeah, it is what it is. So we have float, and then we have double, and then we have something that we call long double. Meaning, but then these days, right, the double data type is actually equivalent to the long data type, right? So they're actually the same. So each of these numbers, right, or each of these data types, they've a specific number of bits that they can store, meaning how many zeros and ones can each data type store. Then we can find a way to translate it to an actual integer. Since we are working with the decimal number system, we can convert it to a decimal number. Then we find out what actual number, what's the maximum that it can represent. So each data type is a minimum and a maximum number it can represent. So by default, all of these types, right, all of them, I think even, I'm not sure about double. I've never paid attention to doubles in terms of signed and unsigned, but you can imagine that each data type, it has two states or two ways, right? We have signed or unsigned. That's how data types are. So I need to change this to C++ so that it highlights, right? So you can actually use the keyword signed or unsigned. Why the word signed and unsigned? Let's explain that short example. Remember, taking you back to maths again. Like I said, if you don't like maths, this is not the place. So remember a number, let's say +1. Remember, there's a rule or a property that says that you can omit the plus and just put the number as itself, right? Just 1. But then with -1 or any negative number, it's not optional. It's a must to put the minus. So in this case, you see that this number, it has a sign, right? It has this sign, this minus sign. That means it's signed, right? And then this one, it is unsigned, meaning it doesn't have a sign or a plus sign. So it's unsigned. And then this has a sign, so it's signed. So what this means that by default, if you declare the variables like this, by default, just like that rule in maths, if you have an x like this, just know there's an invisible 1 there, just like that rule. Even here in programming, every data type you create, even if it's a char, except for string, even if it's a char, short, int, long, blah, blah, by default, it is a signed keyword. You can put it manually on your own, that's fine. But by default, it's added for you by C++. Then when you want a specific value unsigned, as you can see, unsigned, I'm sure you can see unsigned, we are referring to positive values. So that means unsigned only stores positive numbers. So from 0, in a way, you can view it as like from 0 to infinity, but not really infinity, because in computers, they can't represent all numbers. So they are limited. They don't approach infinity. They never approach infinity, the numbers stored in a computer. So just keep that in mind. So it's unsigned, meaning it's positive to some limit. But then by default, if you declare them like that, by default, they are signed, meaning I know signed is weird, but signed, it means that the variable or the data type accommodates both negative and positive values. Unsigned, meaning that there's no sign, meaning only positive numbers. So unsigned, it means that it's positive numbers. So signed would mean you represent positive and negative. So you store both numbers and negative numbers, right? And then unsigned, as the word suggests, unsigned. There's no sign. And if there's no sign, that means there's no negative numbers. So this means that this is positive numbers only. So it's up to you. If you have a preg and you expect your numbers to be only positive, you should use unsigned. But then the author of C++ advised you not to use it, but it's debatable. Just use it. You're a beginner, you're allowed. Use it. Because it's there for a reason, right? So use it. So this is char, this is blah blah, all these things, right? So a char, it's actually 8 bits inside C++, right? It's 8 bits. I think I made a serious mistake here in Java when I was teaching them. You see, when you're teaching many languages, you can end up mixing things up. In Java, char is actually 16 bits, but in C++, it's only 8 bits, and it's signed by default. You can make it unsigned, that's up to you, but it's signed by default, right? All of these data types are signed by default. Even the float and the double, they are signed by default. I'm not sure if you can say unsigned for a double. I'm not sure. Let's try to do that. Like I said, I do a lot of languages, so sometimes I tend to forget some things. Yeah, I don't think there's an unsigned positive. Yeah, there's no, it only applies to integers. Yeah. No, I want to view logs. It only applies to integers. Don't use unsigned on floating points. Yeah, it's invalid. So I just needed to double check that. So don't do spiritual things. So a short, if you notice something there about these types, they go in ascending order, they increase. So they start from the smallest, which is a char, then goes to a short, then it goes to an int, then it goes to a long, then it goes to a long, which is the biggest, right? In terms of integer number, representing integers. If you want to represent numbers with a decimal point, use float or double. But then float is bigger than any integer type. So that means the biggest one after long is float. Then the biggest of them all is double. Remember, long double is just now double. They're all the same size. So you can just use double. But then the one after that will come after double would have been long double if it wasn't the case anymore. But then now things have changed. So you don't have to use long double. So this will be 16 bits, right? And just notice something, it doubles in the direction that it goes. So if it was 8 on char, 8 times 2, that means short will be 16. And then we go to int. What is the previous size or number of bits? It's 16 times 2. This will be 32. So it doubles. So look at the numbers. They actually double. So don't try to cram them. Try to understand how it works. And then here, don't assume it's 128, right? Don't do that. But then the thing is, this is tricky, right? Okay, yeah, nowadays, right, the long data type and int, they actually have the same number of bits. Like I said, C++ has evolved, it has grown. So things are slightly different. So if you want to use a bigger number, you have to actually use a long, right? So it's actually 64 bits. And then this one is 32 bits. And then this one is 64 bits, right? But then this 32 bits, just know that it's bigger than all integer types, all of these types, because this one can represent both quotient and remainder. It stores both. Remember, it's a float. If it says 2.5, that number includes the remainder and the quotient. So it's bigger than just a normal integer. If you look at it from a mathematical perspective, you can realize that they're actually bigger. Then how do you find the numbers that the range of numbers that each data type can store? Remember the char type, we use it to represent we're actually representing the integer numbers for the characters, for characters. Hence it's called char, which is an abbreviation for character, the word character. They took char from the word character. So it's not actually meant for you can use it for mathematical purposes, but we are looking at storing characters. So they took the word from character, then they deleted from A, and then they just called it char to keep it nice and sweet. So how do you find the range of values that each variable can represent? If it's signed, right? If it's signed, right, meaning you can accommodate negative and positive, we say -2 to the power of n minus 1, right? Up to, right, positive base 2 to the power of n minus 1. And then that result, that whole result, especially this whole result over here, you subtract 1. Why is that minus 1 important there? This minus 1. We're subtracting it because in our range, we'll find out that from negative something, right, some value. In this case, I'm going to say negative infinity, but just remember, we can't represent infinity in a computer. Then minus 2, minus 1, then 0, then positive. Remember, you can omit the plus, so 1, 2, 3, and so forth. So this minus 1, right, this one at the end, right, is to exclude 0 in our range of values. So it's like we're deleting the 0 in our range of values. So that's why we always put the minus 1. We subtract the minus 1 from the upper bound, right? And remember, it's inclusive for those like us. Everyone has to be, they did pure maths, so it's inclusive. So in other ways, you can represent it in this way if you want to picture it in that way. It's inclusive. So would be this. Yeah, so this is the formula where n represents the number of bits. So n represents the number of bits, right? So that's the formula to calculate the number. Basically, you calculate the range of values that each data type can store. So if you're working with the app that calculates, let's say it calculates, what is this? Let's say it's an app that's not really an app, but you're making a practical based on your research. Let's say you're doing PhD in maths. That means you need very big values. So that's when you're going to be using things like long, and double. That's what you're going to be using. So you're going to use long, and double because in your application, you're going to need very big values. But if it's a small app, for example, it's like a prac and you're keeping track of the marks for the practicals, you need a range between 0 and 100, right? Because that's the mark range. So you don't have to use a bigger data type. Always use this. Try to use smaller data types because the bigger the data types, the bigger the space. By space, we mean that when you look at your file, you see all these bits that I'm talking about, right? They add up and become what we call kilobytes, megabytes. You see all these KBs here, those KBs here. It's kilobytes, right? Which means that if I'm not mistaken, each kilobyte is equivalent to 1,000 bytes. Yeah. So each kilobyte is equivalent to 1,000 bytes. So you can do the maths behind that. So we don't want our files to be very big and waste unnecessary space, right? So we try to use the smallest possible data type which can accommodate all of our values. So for example, if you'll notice from now on in my practicals in the solutions that I'm going to write, right, in the past papers, I'll normalize using short because it's big enough to represent the things that I want to represent. So to check the range of values that a chart can store, you just say -2 to the power of 8 minus 1, which is just 7, up to +2 to the power of n minus 1, which is just 8 minus 1, which is 7. Then that whole result is subtract 7 to exclude 0 in our range. So this will be the number of values, right? If you check in your calculator right now, this will be from minus 128 up to exactly 127. So this will be the number of range of values you can represent by using a chart, which is sufficient here, right? Because if you look at our ASCII tables, most of these values, they don't reach like 127. I think the maximum is 127. Yeah, you see, the last number is 127. So it's sufficient. It's enough to represent all these characters. And these are only the characters that are listed on your keyboard. If you look at these characters, right, they're actually all the characters on your keyboard right now. So 32, all these numbers. So this is the range. You can also check the ranges for other data types. That's not the point. I don't want to type everything. But I made one example. You guys get the example. Remember, long double, I said it's the same as a double, so it's also 64 bits. So there's no need to worry about long double. Just call it a double. So let's see. Yeah, so how to declare a variable. So to declare a variable, you put in the data type first. Very important. After the data type, you put in a space. You don't put in a space, C++ doesn't understand what you're trying to do. Then you put in the variable name. Then semicolon to end that statement, just like you'd end a sentence in English. So you need to end that statement with a semicolon. You don't end it, crash. C++ has no sympathy. There's no emotions. Not gonna feel for you and then try and understand you for God. Doesn't care. Do the right thing. There's no room for errors with C++. So how would you name the variables, right? Let's talk about that. Since we understand the different data types. Remember I said we're going to talk about strings and whatever, all these other data types when you get there. So how do you name variables? So you're going to have how to name variables. So to name variables, right? Variables can contain letters, digits, right? And underscore character, right? So that's what C++ variables can store. It can contain letters, meaning letters of the alphabet from A to Z. That's what I mean. Then digits from 0 to 9 and an underscore, right? It can contain all those three. Then it's up to you what way you want to name the variables. I like to use something that we call camel case, right? Camel case because after looking at the variable, it looks like the camel's humps, right? If you know a camel, you guys should know a camel. If you know a camel, it has humps, right? So camel's humps. So it has humps, right? So basically what they're trying to say is that that variable, when you use this technique, if you were to draw a line, it was going to look like a camel's humps. You see how the camel's humps look? So I'm gonna make an example right now of some variable, right? So let me show you that this holds true, right? Let's try to prove this statement, right? So let me add text here. Yeah, so I'm gonna say num students attended, right? We just stores the number of students that attended, right? So okay, this is not, let me do this. Just give me a sec. Yeah, this thing is annoying, man. I need to get a laptop that can allow me to draw. So num students attended, right? Let's say that's the variable that you created. You see, if basically the first word the first word in the variable name, it's in all small letters. Then you capitalize the first letter of each word after that. So you see num is just one word, right? That num is just on its own. It's in all small letters. But then students is another word. So I capitalized letter S. Then attended is another word. So I capitalized letter A. So that's what we call camel case. If I was to draw, now you see why it's called camel case, because if I was to draw a line, every time I see a capital letter, I go up, right? So you're gonna see, you're gonna draw like this. There's a capital letter here, S, and then it goes up like that. There's a capital letter A, and then it goes straight like this. So as you can see, this kind of looks like a camel's hump, right? I get it's like this, and then so forth, right? So that's why they call it camel case, because it kind of looks like a camel's hump. So that's how we're gonna name our variables. You guys have been doing spiritual things with naming variables. It's do you know that the way you name a variables can decide whether you're getting hired or not? Because it shows how much attention you pay to detail. That means you're a very clean person. Writing code can kind of tell you a lot about what's going on in someone's brain when you look at someone's code. If it's scattered, it's all over the place. Yeah, in your head, you're all over the place to some extent. So it's very important to follow the rules of a language. When they tell you to use camel case, use camel case. And then make sure, right, you do not start variables with an underscore, right? An underscore or a digit, right? Make sure your variable doesn't, even though an underscore is allowed, but don't start with an underscore. Why shouldn't you start with an underscore? Because most of these compilers that you guys use, they're variables that are created using starting with an underscore. You might create a variable with the exact same name. Then it's going to cause something that we call linker errors, which is very deep. You're going to get so many spiritual errors that even Dr. Strungu doesn't know what's wrong with your code. He will tell you straight, me, I don't know. I've never encountered such spiritual errors. So don't be doing spiritual things. Don't start variables with an underscore. And make sure you use camel case. Your code should look neat and pretty. It should represent you as a person. So this is mainly the rules. There could be more. Okay, yeah, I'll just name one extra one. A variable can be of any length. Don't abuse this property, right? For example, let me show you an example of a very wrong way of using this property. This is a very long variable name to use. You see how long this variable name is, right? Can you honestly tell me you're gonna remember this variable name when you have like 10 files? You're gonna bound to make a lot of errors because the variable name is too long. And try to use, right? And I think this should be the last one. Try to use descriptive words to name variables, right? For example, right, instead of calling it A, call it average, right? Because it's self-explanatory. Average, it calculates an average. If you just say A can be anything, right? So don't do that. Don't use weird names. I know sometimes, since you guys are beginners, Dr. Strungu likes to say that before the name of each variable, right, put in the data type. So for example, if it's a double, so double, you just say DBL for short for double, followed by the variable name itself. Remember, we're using camel case. So the next word is average. So I need to capitalize its first letter. So average, DBL average. So that I remember when I'm coding, oh, this is a double. So that I don't try to store a string in there. That's the only reason why you do that. But to be honest, in the textbook, not in the textbook, I read it somewhere. They said it's outdated. Don't name your variables that way. But since you guys are beginners, I guess it's allowed because you might forget the data types of things. Then now that's basically how you declare. Let me show you examples of variables. So examples, you have double average. That's a proper name, right? Average, straightforward. Then now to initialize variables, right? Initialization. You use what we call the equal sign, which is an assignment. It's called an assignment operator because it assigns a value for our box, right? Basically, we are inserting or putting into the box something, right? So to put into the box, if you look at our diagram, right? If you go back to our variable diagram, we have our box, right? Let's say this is the box. Let me go back to Notepad. So we have our box average, right? It has the label average, and we told C++ that it can only accept anything that's a double. So what we're going to do is we're going to initialize. Let's say average is equals to 10.0. So this is how you initialize it. You put in a variable on the left-hand side, space, followed by the equal sign, space, followed by the value, right? Make sure the value is the same data type as the data type of the variable itself. You try to put a different data type, it's like you're trying to park a car in a microwave. I'm going to repeat that now. That's very stupid to do that. When you try to do that, try to remember my word that that's very stupid what you're about to do. The computer doesn't work that way. Each box has a data type, meaning that it expects that thing in the box. You try to put something else, the computer thinks you're stupid. So Don't be doing that. Or if you want to abbreviate and write a shortcut, like instead of declaring it separately, then initializing separate, you can combine it. So this will be the formula. You can say data type space followed by the variable name, space followed by an equal sign, space followed by a value, and a semicolon. That's another way to initialize it. So you can say double average is equals to 10.0, right? So that's the average. So this will be how you initialize the variables. Then to use your mathematical operators, I'm just going to list them. Then we can end our session now. Let me see. I think, yeah, it's almost 2 hours. I wanted to be under 2 hours. So let's do that. Now let's list the arithmetic operators, right? So we have what we call arithmetic operators. Basically, operators we use to do arithmetic, basically maths related calculations. So we have the plus, which means addition. And then we have the minus, which means subtraction. And then we have the star, that watashi wa star, which means multi. Now I can, this auto suggestion thing, now it blinds me from seeing what I'm typing. So that star stands for multiplication, right? Then we have a /, which stands for division. Remember, we talked about division, right? If you say an integer, some integer divided by some int, this gives you back what we call a quotient. If you remember in maths, gives you a quotient. But if you want to get back a double, try to make sure that each of these things is a double, or it's either one of them or both. They have to be a double. Because there's something inside a computer that we call the CPU. I was explaining this exact same thing for my computer science 2A students. There's something called the CPU, right? Which is basically the brain of the computer. The brain of the computer, the way it works, right? It expects you to add or multiply or divide variables of the same data type. The moment you mix, it's going to have issues. It's going to have unpredictable behavior. So that's why if we want to get, if we have two integers like this, we get back what we call a quotient, right? But then if you have a double or an int on either side, whether it's the numerator or the denominator, whether you have a double, and remember this would be the numerator on this side, and followed by the division sign, then followed by the denominator. That's how it looks, right? So when I say numerator and I say denominator, be sure to look at the right side. Don't be looking at the wrong sides. So you can either make the numerator to be a double or make the denominator to be a double, or both. Both is not really necessary because C++, as long as this is one of them is a double, it's going to promote the other one to be a double. Just like you'd get promoted at work, something like that. It will promote it, or what I like to call casting. It will cast it to a double. So if you're working with literals, right, meaning literally those values, you don't have to use a cast. You can just divide it by that double version of that number. So for example, you have sum divided by 10. If sum was an integer, of which it will be an integer if you are working with practicals, because practicals are marked out of 100, which is an integer. So this is integer divided by integer. So this will return a quotient. What if we don't want that? We want it to do proper division. You don't have to cast here, right? It's not necessary because you have a literal value here. Casting is only when you have variables, right? So here a variable and a literal. So I can choose to convert the literal to a double or for it to be treated as a double. So 10.0. What happens is that C++ will see this sum and check, is it a double? If it's not, it's going to cast it or treat it as a double only for that calculation. It doesn't change the data type of sum, but it just treats it as a double only to do that calculation. That's what casting does. It's a temporary thing. It's not permanent. Then we have the percentage sign, which stands for modulus, right? Or mod. right? Basically, this if we divide two integers like this and we get a quotient, we can use this symbol to get a remainder. So this gives us the remainder. And obviously, if you remember maths, if you did your maths well, the remainder is just to be an integer. For example, 3 divided by 2. It's 1, remainder 1. Because 2 goes into 3 ones, and you're left with the number 1, which is an integer. So remainder is always an integer. So that's why when you use the percentage or the modulus operator, you always work with integers. Don't do spiritual things and mix doubles and what. Me, I'm a very impatient man. I might say things that you're not gonna like. Before you come to me and you've attended the session, and before you come to me and you know you did spiritual things, make sure you revise the recordings. You watch the recordings again thoroughly before you come to me. Because of like I explained this thing. Now you want me to explain it again. Where is it there in the recording? With modulus, you do not ever work with doubles. It's only integers. Unlike this division, it's fine with the division operator because we can either want the quotient, that means we'll use integers, or we want it in a decimal form, right? Meaning we want the quotient and the remainder combined into one number. Then we can use doubles, or one of the values is a double. So before you come to me, make sure you know you're doing the right stuff. So we'll end here. Then I think later on we continue with if statements. Let me see, if statements, I'm skipping. No, I think you can go to continue with variables and then talk about pointers, right? Yeah, remember, just something quick before we end the session. Remember, I talked about each variable having an address, right? How do you get the address of a variable? There's two ways, right? You can call the function called address of, right? Address of. There's a function, I think it's part of standard namespace. Yeah, you see, there's the std. It's part of standard namespace. Then you pass in the variable here, right? That you want to get the address of. That's the first way, right? So you can just say cout and you say you want to get the address of value1 variable. So it's gonna tell you in which location it's stored, of which you won't know. It just show you, I'm not showing you the address. You don't, and you see that I didn't lie, it's in hexadecimal. You see the address, but you don't really care how it looks, right? You don't really care how it looks. All you just care about is being able to work a point and tell C++ to go to the addresses. It's kind of faster in a way. You realize how fast that is. Or you can just do this. You put the variable name there and you put in an ampersand, which just stands for address of this thing. So it means get me the address of this variable. So we're gonna need to become quite familiar with that, right? Because we're gonna talk about pointers. So there's it's the exact same address, right? That address, right, that I'm getting here is this same address that I was talking about here. Remember, each shelf, each variable is stored in its own shelf, whereby it is an address. So I didn't lie. You can get the address of that variable or of that shelf by using the box's the label on the box, which is the variable name. So there's the addresses. They're in hexadecimal. So yeah, that's quite a lot to take in. That's a lot of information. That's why I said you guys should attend. And yeah, so these are the different variables to initialize. And I should have taught you the other ways to initialize, right? Mind you, pay attention. Mind you, this techniques that I'm teaching you, right? It's only for initialization. Don't try, for example, you want to update your variable and say plus equal, but that's updating the variable. So that's different. So when it comes to initializing, there's multiple ways to initialize. By initializing, right, it means that you declared you have a data type there. Basically, in the process of declaration, and you also want to initialize, that's the only place you should use these techniques. So the second way to initialize is using a list initializer. So average, then use a list 10.0, use curly braces basically. Then that's done. These two things are equivalent. It's exactly the same thing. But the curly braces are limited to only initialization. Don't be doing spiritual things and say average curly brace like that, trying to update. It's gonna crash. It's most likely gonna crash. So don't do that. That's why I try to avoid teaching this way, but it's fine. You can learn a lot of things. Then there's a this way or this technique of initializing, whereby you put in round brackets next to the variable. Then you just say 10.0. So C++ is always C++ always is multiple ways to do things. It's a lot. You choose the technique that you want to use. I would most likely use this one, the second approach, only for initializing. But if I'm updating variables, only use the equal sign or the assignment operator. Like I said, these two techniques over here, they only apply if you have a data type there in the variable and you want to initialize it at the same time while you're creating it. The code, they're used when you're initializing. That's why I said the word initialize, not when you're updating variables. Or else it's going to crash. So don't be doing that. So I'll convert it into a PDF to store all of these answers, right? Everything that I wrote in a PDF and send it to you in the group. So yeah, I'm gonna also give you homework for input and output, right? Because cout is, you understand cout now. You understand the manipulators. There's nothing new there. So I'll give you homework on that now. I'll send it in the group now after the session. So for those who've attended, thank you for attending. Hope to see you in the evening class. Hope you guys have a lovely day.